All right, now we're going to look at making decisions about a null hypothesis from a confidence interval. So it's combining what we did in this chapter with what we've done the rest of the semester. And so this is a hypothesis for the amount of grams of sugar in a candy bar, where the null hypothesis of the mu was 20 grams. The alternative is that the mean is not 20 grams. Now, a 95% confidence interval was done to find it to be between 23 and 34. What does this say about the null hypothesis? Well, let's think about this for a second. A null hypothesis, if I draw out a normal distribution, we set up a model where the mean is 20. So if we think that the true mean is 20, in a hypothesis test, we want to see how often we get a value that's far away from 20. Now, if we do a confidence interval, and I find out that the true mean is between 23 and 34, we think that the true mean is somewhere out here. Is it possible for the mean to actually be 20? Your answer should be no. And so here, we reject the null hypothesis. We have evidence that the mean is different than 20 because it's out here. So if we just give you a little bit more specifics here, now a 95% confidence interval corresponds with a 0.05 alpha level. So this is alpha and this is confidence interval. Now, if I have a 99% confidence interval, that will help us with a 0.01 alpha level. And a 90% confidence interval will help us with a 0.1. Of course, 92% would help us with an alpha level of 0.08, and so on all the way through. And so these confidence intervals can help us reject or fail to reject based on these values alone. So you just keep in mind that you're using that connection only. You're not using 95 with a 0.1 significance level. So let's look at this next one. A Framingham Offspring study. Participants attend clinical examinations approximately every 4 years. Suppose we want to compare systolic blood pressures between examinations. That's changes over 4 years. The data below are the systolic blood pressures measured at the 6th and 7th examination in a subsample of 15 randomly selected participants. Now, the 90% confidence interval was that the difference was between negative 12.4 and 1.8. Should we reject a null hypothesis that there was no change in blood pressure? And what significance level should this match to? So if our null hypothesis would be that there's no change, that would be the mean change is 0. So if I drew this out real quickly, so we have, if we're doing a significance test, we would have our null at 0, and we'd build a model around that. And then if we went from 1.8 all the way down to negative 12.4, is it possible for the mean to actually be 0? Yeah. So in this case, we failed to reject a null. We don't have any evidence that the mean is different than 0. It's possible that the mean's down here. It's possible that the mean's right here. We just don't have any idea. So we fail to reject the null hypothesis because 0 is in our confidence interval. Now, what significance level does this match up to? So this is a 90% confidence interval. So our alpha, or our significance level, would be 0.1 that it matches up with. All right, and that is our last video. Hope you can do your own notes.